This video is on surface area of cones. So you'll notice at the bottom of this slide, you have two formulas. You have one with lateral area, and that's the LA, and you have one for surface area, that's the SA. We're not going to focus on lateral area, we're just going to focus on surface area. Right? Now our surface area says pi RL, that fancy little L there, plus pi r squared. So the r we know is radius. The L is called the slant height. So we're not taking the height that's going through the center of the cone, forming a 90-degree angle with the radius. We're taking the slant height, which is the edge of the cone itself. So we want that distance, not the vertical distance of our cone like we would for volume. So if we take a look at this first example here, our first example here, we have our slant height, which is 13. We have another height, which is 12. So that's just the regular height. We would use that for volume if we were going to find volume. What we need is the radius. So naturally, we have a right triangle that's formed there. So we're taking a squared plus b squared equals c squared. One of our sides is going to be the r that we're looking for, 12, and our hypotenuse is 13. So we have r squared plus 144 equals 169. And when you subtract 144, you get r squared equals 25, so your radius for this is going to be 5. Using that information, now we can go ahead and we can take our surface area formula, which we just said was pi RL plus pi r squared. So if we plug in all of our information, we have pi times 5 times 13 plus pi times 5 squared. All right, so now I'm going to leave pi for as long as I possibly can here. So 5 times 13 is going to be 65, so we get 65 pi. Okay, and then 5 squared is just 25, so we get 25 pi. 65 plus 25 gives us 90. So the surface area for this cone is 90 pi units squared. If you have a problem that says to the nearest tenth, you can take the 90 and you can multiply it by 3.14 to get a decimal answer instead of in terms of pi. The next one that we have is actually two cones combined. And if you think about it, surface area is like painting the outside of a shape. So what we have is we have two cones and we want to paint the two of them after gluing them together. Okay? So if we take a look at this, one, we have the radius, and we have a regular height for both of them. We don't have a slant height. So we need to find L on this one, and we need to find the L on this one, so I'm just going to call this one X to keep it kind of separate. So our first one, we're going to have 8 squared plus 15 squared equals L squared. Right? So we can go through our formula the way that we've done many times before, and we can take 8 squared, which is 64, 15 squared, which is 225, and that's going to equal L squared. So we have 289 equals L squared. So 17, once we take the square root, is L. Okay, and on the other side, we have 15 squared plus 20 squared equals X squared. So we have 225 plus 400 equals X squared, so 625 equals x squared. So when we take the square root, we get 25 for x. Now, the one thing to consider about these two cones is when we put them together and we glue them, this part here is not going to be visible anymore. So we actually wouldn't end up painting it. We would just end up painting the other part, right? So when we look at the surface area for these two combined, our formula is this, but the pi r squared is the circle that's at the bottom of this cone. So we actually don't need this. So we only need the pi r L part. So we're going to take both measurements that we have, and really we're going to do pi r L, and I'm going to replace the L with my pi r x that we calculated. So in our smaller one, we have pi times 15 times 17. And in our bigger one, we have pi times 15 times 25. Sorry, got a little squish there. So if we go through this, again, I'm going to leave it in terms of pi. 15 times 17 is going to be 255 pi. And then we have 15 times 25, which is 375 pi. So when we add these guys together, we have 375 plus 255 is 630 pi units squared. And it's all because we didn't have to take into account that circle that's going to disappear when we glue the two cones together.